We're going to start this lesson, Reflections of Functions, by talking about or thinking about our parabolas. So in the last chapter, we did reflections of parabolas. We had happy parabolas, we had sad parabolas, but when we're doing this lesson today, we need to think about functions in general. So we are going to be going through this lesson using g of x and f of x and just thinking about functions in general. But if it's easier for you to think about a parabola as we start the lesson, that might be a really good idea. So a reflection is a transformation in which a figure is reflected over a reflection line. We are going to be talking about multiple reflection lines today, typically our x-axis and our y-axis. The graph of g of x equals negative f of x is a reflection of the graph of f of x in the x-axis. So I'm going to go ahead here and I'm just going to draw a grid for you. The first thing that I'm going to do is do f of x is equal to our base function for a parabola, x squared. Now, this is saying that g of x, so our new function, is equal to negative f of x. We already know that if I had to do negative x squared, it would be the exact same parabola, but it would be sad or open down. So when we're talking about this, it's pretty easy to see if we think back to parabolas that negative f of x is a reflection in the x-axis. So if you're thinking about yourself in kindergarten and you were to paint this red function right here and fold your paper over the x-axis, we would get this green reflection that is shown. Mathematically, if we're talking about points or image points like we were in the past, any point x, y in our f of x is going to become x negative y. So for example, if I have this point right here, 2, 4, when it's reflected, it's going to become 2, negative 4. So the x-coordinate doesn't change. It still stays an x, but the y becomes the negative version of itself. The next reflection that we're going to be talking about is h of x equals f of negative x. So what you're going to notice now is that this negative sign is inside of the brackets with our x. It's not out front of the entire equation. As I'm sure you're thinking right now, that means that it is not a reflection in the x-axis. So now our reflection is in the y-axis. So this time, just for fun, I think that I'm going to draw this base function. So for those of you that are trying to think ahead, that is the base function square root x. Now, if I imagine every single x value being negative or becoming negative, that would mean that my reflection would go over the y-axis. So my new graph, or my h of x, would look like this. Now, if we're thinking about points or image points, we're going to use the point 4, 2, and over here, that exact same point would become negative 4, 2. So if we're writing that just in general terms, then a point x, y becomes negative x, y. So the y value stays the exact same, but the x value becomes negative. Sometimes we can have both reflections. So in this example, we have s of x is equaling negative f of negative x. So this first negative out front is the reflection in the x-axis, so the up-down reflection, and the second negative is the reflection in the y-axis, so the right-left negative. So if I'm going to draw a grid right here, and I'm just going to use a parabola again. It doesn't matter where. This is not our base function x squared. This has been transformed just so you could see better. If we have the negative f, so this first negative, this is the reflection in the x-axis. So this parabola needs to become a downward facing parabola. This is what changes the y value. The y become negative y. Now we also have this negative inside the brackets. That means that the blue parabola that I just drew gets transformed over the y-axis. This means that since we have both transformations, our point xy becomes, in the blue, x negative y, and then that point becomes, in the green, negative x negative y. So both reflections mean negative x, negative y. Now some of you may be thinking, what if you did the reflection in the y-axis first and then the x-axis? But as you can see by the picture, it would be the exact same. So if I took my original function, this red function right here, and I did the reflection in the y-axis, it would become over here, and then if I flipped it in the x-axis, I would get the exact same function that I drew here. Our last example, so given the function f of x equals the square root of x plus 3 subtract 4, write an, ignore that d there, write an equation to represent the following. So the first thing that we're going to do is h of x is a reflection in the y-axis. So we remember that the reflection in the y-axis means that we need to have our negative inside the bracket with the x. So that means, so h of x equals f of negative x. Now, my function, my f of x, is the square root of x plus 3 subtract 4. This means that everywhere I see an x, I need to replace it with a negative x. So this is going to become the square root of negative x plus 3 subtract 4. Now for b, sorry, I can't simplify that any further, so I am just done. I just do want to mention, I guess quickly, that I can't add this 3 and this minus 4 because the 3 is inside of the square root and the 4 is not. So going back to b, we have r of s is equal to a reflection in the x-axis. So we know that this is negative f of x. All this means is that I'm really just putting a negative outside of my function f of x. So negative square root of x plus 3 minus 4. Now I can simplify this a little bit further, so this negative does need to be multiplied through every term in here. So negative root x plus 3, and then this subtract 4, since it's being multiplied by the negative out front, is going to become a plus 4. Now, this last example, I'm going to try and squeeze it in here. S of x is equal to a reflection in the y-axis and then the x-axis. This means that I'm doing negative f of negative x. So not only am I putting a negative out front of my entire equation, I am also putting a negative x in wherever I see an x. Now I am again going to multiply this negative through, and so I am going to be getting negative square root of negative x plus 3 and a plus 4. Now, I don't really like seeing this negative x underneath my square root like that, so I am just going to be factoring that out. So a negative x minus 3 plus 4.